Welcome to the acceleration investigation. We're going to be finding the acceleration of these three objects today. And in order to do that, we need a super long ramp. Notice that the ramp is separated into four sections, with 4 being at the bottom, and then 3 and 2 and 1. In order to find the time that the objects pass through each section, we're using our awesome sophisticated equipment provided by my teacher friend, Mrs. Raybold. So what we're investigating today are the questions at the top of your paper. The first one is, where's the rolling object going the fastest? And the second one, which object has the greatest acceleration? To do that, we'll be filling in 4 data tables. The first one is marked steel marble. You can see that it has a place for each section of the ramp, as well as a time, a distance, and then you're going to be calculating the speed. Let me show you how we're going to find the distance. With our timekeeping device, we need to measure the distance between the 2 laser beams. The 2 laser beams actually go through the middle, from that point to that point. And the distance there is 3 centimeters. However, if you notice on your paper, you need the distance in meters. So, how do we convert centimeters to meters? We need to move the decimal point 2 places to the left. So our distance is 0.03 meters. So you can fill in 0.03 all the way down on your data table as your distance. So in order to find the speed, we have the distance, and as you can see, we need the time. So we're going to find the time for ramp section 1. These are called photo gates. When the marble rolls through the 2 laser beams, a time is going to appear on the readout meter. So let's go ahead and roll the marble through the first photo gate. And the amount of time it took to cross those 2 laser beams in the photo gates was 0.0185. So that's what you record as the time of the first ramp section for the steel marble. Next, we're going to find the time for the ping pong ball and the golf ball. So here goes the ping pong ball. Ramp section 1. And our time for the ping pong ball was 0.0215. Make sure you're writing that in the correct data table. And next is going to be the golf ball. All right, ready for the golf ball? On your data table for ramp section 1 for the golf ball, you're writing 0.0185, just like that. Moving on to the data for ramp section 2, steel marble. Ready? And our ramp section 2, steel marble, is 0.0129. Make sure you write that in the first data table. Now, for the ping pong ball, ramp section 2, ready? In our second data table, ramp section 2, our time was 0.0162. And last but not least, in ramp section 2, the golf ball. Here we go. For ramp section 2, the golf ball, the time is 0.0131. Make sure you're putting that in the data table marked golf ball. Ramp section 3 for the ping pong ball, 0.0145. And last but not least, the golf ball. Let her rip. Time for the golf ball, ramp section 3 was 0.0116. Okay, we're all set up at ramp section number 4. Let's go. All right, our steel marble, 0.0101. On to our ping pong ball. Ping pong ball, 0.0138. And last but not least, the golf ball, the golf ball's time was 0.0104. So at this point, you should have all of this information filled in on your data table, and we're going to move on to finding some speeds. Okay, now that we've collected the data for the accelerations of the steel marble, the ping pong ball, and the golf ball, we need to continue thinking about these questions. Where is the rolling object going the fastest, and which object has the greatest acceleration? In order to come up with those answers, we need to do some calculations. So if you think back to calculating speed, we know that speed equals distance divided by time. So what we're going to be doing is taking our distance and divide it by the time it took for each ball to roll that distance. Now, remember, this distance is just the distance between the two laser beams. So between those two parts of the photo gate where I originally measured, that's this distance that I'm talking about here. Okay. I will show you how to do the calculations for the steel marble, and then it's going to be up to you to do the ping pong ball and the golf ball. So let's bring up our handy dandy calculator. And what we need to type in, either to your calculator or on here, is 0.03 is our distance, divided by the time, which is 0.0185. Make sure you have that second zero after the decimal point. And you can see here that the calculation turns out to be 1.621621 blah 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 blah. Now, as I always tell you, you need to round your information to the nearest decimal point, whatever that happens to be. To round, you go to whichever of your measurements has the least number of decimals. In this case, that would be the distance. So the distance goes out to the hundredths, so we're going to round to the hundredths. In order to round, you have to look at the digit in the thousandths place. On our calculator, you'll see that the digit in the thousandths is a 1. So if the digit is 4 or less, you leave the hundredths alone. If the digit is 5 or greater, you round the hundredths up. Since this digit is a 1, we leave the 2 as it is, and the speed for the marble in the first section of the ramp was 1.62. Okay, let's do the speed in the second section of the ramp. Distance first, 0.03 divided by 0.0129. Again, round to the nearest hundredths. This isn't a big number. It's a small number with a lot of digits attached. So 2.325 rounds to 2.3 what? 3, you're right, because the next digit is 5 or greater. So our speed here is 2.33. For the speed in the third section of the ramp, type in our distance first, 0.03. Make sure you're typing distance first always, divided by 0.0108. And we have 2.777, so that rounds to 2.78. And one last section, 0.03 divided by 0.0101. And we have the final speed at 2.970, so 2.97. Okay, it'll be your responsibility to fill in the speed for the ping pong ball and again for the golf ball. Okay, now that you've calculated the speeds for the steel marble, the ping pong ball, and the golf ball, it's time to calculate the acceleration. I've given you the acceleration, I've given you the total time that it takes for the marble to go the whole length of the ramp. So fill these data points in now. We'll need those in order to calculate acceleration. The steel marble from very beginning to very end was 1.90 seconds. The ping pong ball was 2.25 seconds. And the golf ball was 1.85 seconds. Okay, now that you have those filled in, let's remind ourselves what the calculation or what the formula for acceleration is. If you look in your textbook, acceleration is equal to the velocity final minus the velocity initial divided by total time. So velocity final would be the speed of the object at the end of the ramp. The velocity initial would be the speed of the object at the beginning of the ramp, and the total time is what I've given you here. So I'll go through the calculation for the marble with you, and then you can do the calculations for the ping pong ball and the golf ball. It's easiest to write out everything before you try and use your calculator. So speed at the end of the ramp for the steel marble we calculated was 2.97 minus the speed at the beginning of the ramp for the steel marble was 1.62. I put the parentheses around this to remind you that you need to do the subtraction problem first before you do the division problem. The time for the steel marble to go the whole way down the ramp, which is using this time here, is 1.90. Okay, now let's pull up the calculator and see what we get. 2.97 minus 1.62. It's important here that you press enter. If you don't press enter, your calculator thinks you want to divide by the last number you just put in. Once you press enter, then you can divide by 1.9. Okay, looks like I need to do that again. 2.97 minus 1.62, enter, 1.35 divided by 1.9. And we get our acceleration of 0.7105. So if we look at the third digit, that's a 0. That means we leave the 1 alone. And our acceleration for the marble was 0.71. What are our units for acceleration? We've got to look at meters per second is our speed, divided by time is in seconds. So our units are meters per second squared. You need to figure out the acceleration for the ping pong ball and the golf ball, and our next step is to learn how to graph this data. Now that you've calculated the speeds and the acceleration of each rolling object that we tested, we need to graph our information. It's always helpful to use a graph to kind of visualize what happened in your experiment. So to set up your graph, you need to open up Microsoft Excel. Once you have a blank screen, you should type in the following information to start our data table. In column A, row 1, leave the box blank. Right underneath there, you want to type in start, section 1, section 2, section 3, and section 4. This essentially it's going to represent the amount of time it took for the ball to roll down the ramp. But remember that we found the speed at each of these 4 places. Then across the top, still in row 1, you're going to type in steel marble, and you can resize the column by clicking here and dragging it apart a little bit, then ping pong, then golf. Okay. The starting speed, which we did not write down on our data table, but the starting speed for everything is 0. We started it from no movement at all. So you can type in 0 and press enter to go down to the next cell or box. Then looking on your data table, under steel marble speeds, you need to type in the following information. 1.62 was the first speed we calculated, then 2.33, then 2.78, and lastly 2.97. We calculated these speeds together, so I don't have a problem putting them in for you. Starting with the ping pong ball, remember the starting point was a speed of 0, and the golf ball was also a speed of 0. You need to put in the information that you calculated, rounded to the nearest hundredth, in the 4 spaces for the ping pong ball and the spaces for the golf ball. I'm not going to do those for you, but I will go ahead and show you how to turn these numbers into a graph. So, to turn the numbers into a graph, start on that empty box that you left. Click and hold down the mouse button, and then drag until you have all of the information in your data table. And then let go. Then go up to the top. You're looking for the menu that says Insert. Over here, you see a number of charts that you can insert. You want to choose the second one, which is line graph. And we're going to choose the first box in all of those options. Right away, the graph pops up. But we have to make some changes to make sure that it is information that is valuable for us. You know, something that we can look at and see and actually understand. If you just look at something, if you just let the Excel do whatever it decides to do, you don't always have the right information presented the way you want it. So you need to make sure that whenever you graph something, you look at the graph. Okay, here's our graph for the speed of the steel marble. We notice that the line is slightly curved uphill. We notice that it color-coded our information for us. Steel marble is blue, ping pong will be red, golf will be green. And if you go back and just start typing in, I'll give you something random like 0.36, it will start the plot for you. So you don't have to wait until all of these are put in order to do the graph. Okay, I'll go back up and erase that since that's not an actual answer. We do need to add some titles, some axis labels to our graph. So let's go up here to click on the graph, and you see the chart tools menus pop up. If you choose layout, first we can choose chart title. You want centered overlay, which is the second option. Click down here where it says title. You can highlight that in order to erase it and then start typing over it. We want the title of our chart to be a velocity dash time graph of 3 rolling objects. Okay? Over here, what I would like to see, right here you can see it gave us an interval of 0.5. So that means it counts by 0.5. 0, 0.5, 1, 1.5, and so on. However, we will get more accurate, a more accurate visual representation if we change this to 0.1. So I'll close this and show you what I did. If you put your cursor right over one of the numbers and double click, this format axis option pops up. All you need to do is go over to major unit, click fixed, and change it from 0.5 to 0.1 and click enter. This changes the interval to a 0.1 interval, so it's a lot easier to read what's going on with your graph. And we can actually expand our graph a little bit so it's easier to read, even more easier. Okay, we do not have a title for this information, however. What does this represent? From 0 to 3.2, what are we looking at here? That's right, this is the speed, since that's what we typed in to our data table at the top of the chart. This is our speed. So, to change the label for that axis, you need to go to Axis Titles. This is your primary vertical axis, and you would like to choose, or you should choose Rotated Title. And then you can click here, and you always put in the speed or the title and the units it's listed in, speed in meters per second. There we go. Down here, we need another axis title for our horizontal axis, and choose show left to right. Let's try that again. Title below axis, sorry. And this is ramp section. We already have our key in color and we have our title, and that's all we need. Once you finish filling in the data for ping pong ball and golf ball, you should have 3 lines right here. To send that information to me, what you need to do is click in the white space somewhere. Right click, choose copy, and then if we go back to our publisher, it says attach the Excel graph here by copying and pasting. Right click again, choose paste. And your graph should be attached right here, so that when you copy it into the submission box, I see your graph as well. Okay, if you have any questions, please feel free to send me a message. Now we're ready to move on to our questions. Looking at the second page, you have 7 questions that you need to answer according to your data and your graph. First question, where? And when I ask where, I mean which section of the ramp was each rolling object going its fastest speed. So find the fastest speed, the greatest number, wherever the number was the highest for each rolling object, and tell me which section of the ramp that was in. Was it the top? Was it the bottom? Number 2, does the speed of each rolling object increase, decrease, or stay the same as it rolls down the ramp? Use your data table and your graph to find out. Does the line go uphill? Does the line go downhill? Number 3, using your book, what is the definition of acceleration? Number 4, did the rolling objects accelerate as they rolled down the ramp? And how do you know? Use that definition to tell me how you know whether the objects accelerated going down or did not accelerate. Number 5, which rolling object had the greatest acceleration? So the steel marble, the golf ball, or the ping pong ball. 6, how does the data in the last data table, so the one where we calculated the actual acceleration, tell you which rolling object had the greatest acceleration? How do you know from that data table? What do the numbers do to tell you which one had the greatest acceleration? And number 7, how do the lines on the graph tell you which rolling object had the greatest acceleration? You actually have to look at all 3 lines on the graph, figure out which object had the greatest acceleration, and tell me how that line is different from the others. And this brings us to the end of our acceleration lab.